We're at SP8.1 lesson 1, and we're talking about data management, which in turn really is talking about graphs. So here we have a line graph. This won't be anything new to you, but we're going into real depth here about how these all work and how to read them. So a line graph is used to show how something changes over time. All right, the strengths of a line graph are that they're easy to read and easy to draw. So when you are actually drawing a graph, make sure you've got a title of what your graph is about. So this graph tells me the value of a car. It tells me the years because this is labeled. If I just throw numbers on there, you can't have people assuming what that means. And it tells me the value in money amounts, and it's going up by $4,000, equally up the side. All right, it can have a zigzag symbol on the vertical axis. That's this right here. Okay, so instead of starting it at 1,000, they started at 8 because that was the lowest number in their data. Okay, if they started at 1,000, there would have been this big gap, and then the line graph would have been like way up higher. All right, so that's allowable as long as you start and increment by the same amount. It's best used to show data gathered over time, and it can be used to estimate values between data points. The limitations it has is you have to be careful on estimating values between data points because the trend might not always continue. Okay? Let's talk about the bar graph. It's a graphical display of data using bars of different heights. I want to be clear on something here. If these were side by side, there wasn't a gap in the middle, it would be called a histogram. So let's make sure our bar graphs do have that spacing in between. Okay, again, nice title. Both axes are labeled. They're going up in increments that are equal on each one. And here we have the strengths. The height of the bars can be used to compare responses. You can look at it real quick and see what's going on. The scale on the vertical axis is 1 grid square, which represents 4 students. This scale can be used to calculate the total number of students who responded, and it's an easy one to draw. Limitations include some people might find this graph difficult to read accurately because none of these bars right here are ending right on the grid line to read across. So they have to figure out there's 4 in between here, so this would be 5, 6, 7. Okay, so it's not a quick look and read. And the graph does not show the percent of the students who chose each response. Okay, looking at a pie chart is a special chart that uses pie or pizza slices to show relative size of data. So the strengths here are it shows a part of a whole. Each response is shown as a percent of the number of students who responded. So this tells us 41% of students for a vending machine survey used it 1 to 3 times. And the size of the sectors can be used to compare responses. Like even putting them in different colors is a really quick way to look at. These two are pretty close, as are these, but really 13 and 11% are quite different, as are 41 and 35. Limitations is the graph does not show the number of students who actually chose each response, and the total number of students can't be calculated from this. And this is a very hard one to draw. You actually have to find your angles and use a protractor and make sure you're ending up exactly perfect. It's probably one of the most difficult. A pictograph is a way of showing data using images. So the strengths here are the lengths of the rows give the symbols immediate comparison responses. You can just look here and you can tell. The key is 1 symbol down here equals 2 students, so you can figure out how many students responded really quick by going 2, 4, 6. And half a symbol represented 1 student. Okay, so 2, 4, 6. This one would be 7. Limitations, there's a lot of symbols on the graph. There's actually 11.5 symbols for 1 to 3 times. Okay, so that's a lot for a small amount of measurement. It might be difficult to draw so many vending machines, so this was obviously done electronically. If you were making a graph, you'd have to draw all these and make them all the same size, otherwise it would be misleading. The graph does not show the percent of the students who chose to each response, so again, that's a limitation. Now, the double bar graph displays 2 sets of data that can be counted. The length of the bars are used to represent and to compare data. These are nice. So they're saying students with a part-time job ages 14 to 18 They have the colors as did not work and worked. They've got the age on the side, the number of students. So at age 18, this many didn't work, this many did work. Okay, they're going up by increments of 2. So I can tell right here that 3 did not work and 22 did. All right. Strength, easy to draw, and can be used directly to compare two sets of data very quickly, like I just showed you. It can only be used to show discrete data, and it may be difficult to read accurately depending on the scale used. Okay, so again, this would be 1. It's not a quick look, but not entirely difficult. Okay, what we're getting to here is misleading graphs. So this is a distorted graph, a graph that misrepresents data. It displays a misuse of statistics and when the result of and gives the result of an incorrect conclusion. Graphs may be misleading through being too complex or poorly constructed. So let me show you what I mean here. Quite often, advertising companies will do this on purpose to make things look better than they seem. Okay, this is from the States, this slide, so favorite isn't spelled right, but we can look past that. So here's 2 bar graphs being compared. Okay, the vertical axis is smaller on graph 2. Okay, so this is a smaller amount. And because it's small, detecting changes in data is easier on graph 1. So it makes it more reliable data. This here is all kind of looking very, very, very similar. All right, here we've got between 300 and 400. Like, what even is that? And when I say small, I mean like it's not, the increments are small. They're going up by 100, but they're not detailed. Okay, so here we've got them all nicely detailed, and you can see exactly 375 apples. Oranges are just a bit higher, whereas here they look quite a bit higher. Bananas are at 250 and strawberries at 400. So just more accurate and easier to read and get the right information from. Here we have average water temperature in Hawaii. You can see that these are very different looking. It's the same information, it's just how it was plotted on the graph. Okay, so what I notice is there's I'm going to look at graph 2 here first. There's a sharp increase in the change in water temperature. So from here to here is a pretty sharp increase and decrease. It doesn't vary greatly from month to month. Okay, and it's really not very reliable. So here the difference is it's gone up by 2s, which in this case temperature 2 degrees isn't a whole lot. Okay, so this one up here they've gone up by 5 degrees. You can see a slow steady increase from 70 to just over 80 here, as opposed to 74 or 70 here all the way to 82. Okay, so this reveals the change in water temperature as more gradual as opposed to really shooting up, and therefore that makes this graph more reliable. Okay, and here's a line graph of prize money. There's a couple things wrong here. Hopefully you see the first one right away. Okay, first of all, it doesn't start at 100,000. So that means that, or sorry, it doesn't start at 0. So we're talking about amount of money here. So that is kind of important. However, you can always put that squiggly line in here as a break if you're going to start this way. So that would make the difference on this one. Okay, and we've got a little bit of an issue here. This is not the same as this. Like, these are all different measurements. So this is not accurate at all. If the spacing isn't even, the money amounts aren't clearly represented, and it looks like the jumps are more drastic than they actually really are. So, just another way of looking at it. In your visual notes are several more examples of misrepresented data and misleading graphs. I want you to make sure you have a look at those before you do your assignment, but you should be good to go. I will see you in the next lesson.